Good morning, grade 11s. Okay, so this video today is going to be on number patterns. Now, I know that we covered number patterns in term 1 sort of roughly before your test. We had a number pattern question in your test, but this video is just going to go into a little bit more detail. Okay, but there's a few things that you need to remember. The first is the difference between a linear pattern and a quadratic pattern. Now, remember, linear patterns, it's your easiest kind of pattern. It basically just has a common difference. So in other words, to get from 3 to 8, what am I doing? Plus 5. To get from 8 to 13, what's happening? Plus 5. And the same thing again from 13 to 18 is plus 5. Okay, so that's what's going on with a common difference. It could be subtracting a number or adding a number, but the number will always remain the same. Okay, now one thing I did not teach you is this formula. You might have done it in extra classes before, I'm not too sure, but this is a formula that might just make your life a little bit easier when coming up with the general formula for a linear pattern, and that is Tn equals A plus n minus 1 d. Okay, so in this formula, A stands for your first term. By the way, I don't have my cookies with me, so it might not be as bright as normal. I've got color pens, but I hope you guys can see. Okay, so your first term is A. So in this particular example, A is 3 because that is your first term. Okay, now remember, as per usual, Tn stands for term number, and n is that term number. So you don't have to worry about that when working out your formula. You will leave it blank. And then over here, what is d? D is your difference. Okay, so in this particular case, what was the difference? Positive 5. So if you wanted to fill in this formula to come up with the general formula, it would look like this. So it's Tn equals A, we decided A is 3, plus n minus 1, I told you you will leave n blank, and d will be your difference. D is 5. Okay, now remember, these two touching just means times. So if I work this out, it'll be 3 plus, and if I multiply the 5 in, it gets 5n minus 5 times 1 is 5. And then if you simplify that, it becomes 5n, 3 minus 5 is minus 2. So do you see that that formula kind of gives you an easier way to get to that without having to think too hard? So if you want to, you are more than welcome to use this formula. Otherwise, you can stick to the old way that you know from before. Okay, now the more challenging one, and I hope that you remember this, this is what I taught you last term, is your quadratic number patterns. Now, if you remember correctly, a quadratic number pattern has a common second difference. Okay, so do you remember? Das Spider. Okay, so das Spider was that little thing that we made the web. Okay, so if this is your number pattern over here, okay, we're going to start making our web. Let me do it in black. Okay, so this is your first difference. This will be a difference, and that will be a difference. Okay, so remember, this is what you do. So what do you do to 3 to get to 8? Plus 5. What do you do to 8 to get to 15? Plus 7. What do you do to 15 to get to 24? Plus 9. Do you remember this? And remember, the spider means we still need to have another little part of our web. So there comes the second part of your web. What do I do to 5 to get to 7? Plus 2. 7 to 9 plus 2. Okay, so remember, this is your web now. This is your second difference, and that is this row is your first difference. Okay, so before you can even answer any questions, this web is very important. Okay, then once you've gotten this web, do you remember you have these 3 formulas? Okay, before you can come up with your main formula. So remember your first one over here, 2a. Remember, we link up the first formula with my second difference. So I would say, in order to calculate A, I will say 2A is equal to 2. Therefore, if I work out A, 2 divided by 2 is 1. Okay, so remember this is part of your 2A. Then remember your next one is 3A plus B, and you move one spider up. You go up to 5 over here. I'm just revising, so this should be very easy. You guys should remember this. So 3A plus B should be equal to 5, the second step. So remember 2A goes with your bottom one. Then 3A plus B goes with this one. And A plus B plus C goes with your top one. Okay, but remember A, you've just calculated it. A is 1. So we can replace the A with a 1. Okay, and then this just becomes 3. Take it over, becomes minus 3. So B is equal to 5 minus 3, which is 2. Okay, so that's that done. And then your last one is A plus B plus C, which you go all the way back to the top, which is 3. So we know A plus B plus C is 3. But do not forget, we calculated A and we calculated B. A is 1 and B is 2. So if I want the C alone, I must take the 1 plus 2 over, so C will just become 0. Okay, so this is just a little bit of revision on what your formulas are and how you work them. Okay, now I'm going to do some past paper questions. The first two are very easy. They're on linear patterns. Okay, so this is, and remember, like I say, this is from past papers. So if you can answer this, you'll be fine for your end of year exams. Given the pattern 7, 2, -3, etc., determine Tn. Now, first of all, they didn't actually tell us what kind of pattern this is, so you're immediately going to go and check your differences. So to get from 7 to 2, what am I doing? Minus 5. Minus 5. To get from 2 to -3, minus 5. Okay, so with these two differences being the same, this is clearly a linear pattern. There's no second difference. The first common difference is equal to each other. They are common. Okay, so determine Tn. Now remember I told you, here is a formula that you can use that will certainly make your life a lot easier. So for linear patterns, you can always use this. Tn is equal to A plus n minus 1 d, where A stands for your first term. So in this pattern, your first term is 7. So 7 plus n, we'll leave it blank because we want that to be blank in our formula so we can put numbers into it. Okay, so then d is going to be your common difference, which, do not forget, it's not just 5, it is -5. So you must replace the whole thing with a -5. Okay, so 7 plus, now we're going to multiply this in. I shouldn't have actually put a plus there because our signs are going to change. It's a -5 times a positive n, which is -5n times a positive is still negative. Sorry, so this will be -5n. Then over here you have a -5 times a -1, which becomes a +5. Times a positive is still a +5. Okay, so we're left with -5n. 7 plus 5 is just going to be plus 12. Alright, so there we go. I have gotten Tn. Now 1.2, they say calculate term 20. So remember, this replaces your n. This is term number 20. So we are looking for T20. That means instead of writing an n, I'm going to write 20. Make sense? Okay, so then 5 times 20 is just -100 plus 12. -100 plus 12, that's -90, -88. Alright, make sense? Okay, and then lastly, 1.3, which term is equal to -138? That means you are now going to take your formula and make it equal to that number, and then you will have to calculate what n is. They are looking for the term number. N stands for your term number. Okay, so -5n plus 5, we're going to make it equal to negative 138. So therefore, if I take my 5 over, let's just do this in one step. So it's negative 138 minus 5, which is going to be negative 143. So minus 5n equals negative 143. Then I must still go and I must divide it by 5. Negative 5. Which is 28. N is equal to 28,6. Okay. Now, this is the first time I'm doing this question and I spot a mistake. Can anybody see what the mistake is? You're welcome to pause this in class if you want to and have a look. What is wrong with this n value? Is it allowed to be a decimal? It is not. Because remember, this is a term number. If I'm counting and I say this is term number 28.6, does that make sense? No, because you have term 1, term 2, term 3, term 4. You can't have term 28.6. So let us go back and review what our problem could have been. And this is a good learning experience, guys. I want you to see when you make a mistake that, yeah, you must spot it and you must fix it. Okay, so we put in 7 as A. That was correct. N minus 1, we put in negative 5 as the difference. That was correct. Okay. Then we timesed out, we got negative 5n, we got positive 5. That was correct. 7 plus 5 was 12, that's correct. Alright, so I'm not too sure what could have been incorrect here. Perhaps there was just a flaw in the question. Let's just see. Yeah, 7 minus 5, that's right. Okay. Oh, okay, excuse me, my mistake. I see here. Copied this incorrectly. This should have been plus 12. Okay, so let's do it over. So it's minus 5n. I don't know why I wrote plus 5. So your formula is minus 5n plus 12 is equal to minus 138. There we go. That makes more sense. All right, so minus 5n. If we take the 12 over, minus 138 minus 12 is equal to minus 150. Then n will be minus 150 divided by minus 5, which is 30. Okay, do you now see we have n as a whole number? It can never be a decimal. I'm really glad that that happened so you could see. Yeah, okay, so just remember it can never be a decimal, and everything else was quite simple, I think. If they ask you for term number, you replace n with that term number. If they ask you which term number equals something, that is when you make the formula equal to that number. Okay, all right, example number 2. Now, this one is slightly more complicated, but it's still simple. It says, this is our numbers over here, 6. Then the next term is 2x plus 1, and the next term is 3x minus 3. It says, are the first 3 terms of a linear pattern, calculate the value of x. Okay, so if they tell us it's a linear pattern, what do you know about linear patterns? You know that the difference is going to be equal. Your first difference is going to be equal, much like we had this over here. 7 to 2 was minus 5. 2 to minus 3 was minus 5. So if I go and I say this term minus this term, right? So watch this. 2x plus 1 minus 6. This one minus that one. Do you agree with me that that's going to be equal to this term minus that term, right? 3x minus 3 minus my second term, 2x plus 1, because they have a common difference. So we can simplify this. It becomes 2x, 1 minus 6 is minus 5, 3x minus 2x is x, minus 3 minus 1 will be minus 4. Okay, take your x over, so 2x minus x just becomes x. Take your minus 5, that way becomes plus 5, so x is equal to 1. Do you see how simple that question was? So remember, when they give you letters in a linear pattern, Basically, they want you to use the fact that they have a common difference to calculate it. So you'll just say, so for these kinds of questions, you'll say term 2 minus term 1 is equal to term 3 minus term 2 because of that common difference. You might want to take note of this. I'm sure you've done one like this in grade 10, but just make a note of it anyways. Okay, example 3. All right. Just remember, guys, you can obviously pause the video in class just to take it down. Okay, we are now moving on to quadratic patterns. Now remember, quadratic patterns is the spider. So you are going to have to subtract them and then subtract them again. Okay, so I'm going to start here 3.1. They want the next term. I'm just immediately going to make my spider because then it will make my life easier. So it's 244, 193, 148, and 109. Okay, so 193 minus 244 is minus 51. In other words, to get from 244 to 193, I must minus 51. Now we do the next one. 148 minus 193 is minus 45. And the last one is minus 39. Okay, then we do the spider again. Now we check minus 45 minus 51 gives me 6. In other words, I must plus 6 to get from minus 51 to minus 45. And I can tell you it's going to be plus 6 again, but let's make doubly sure. Minus 45 is plus 6 again. Okay, so clearly our second difference is equal. And there's our first difference. Okay, not equal. They want the next term. Okay, they want what comes over here. So basically, if I work backwards, I need to plus 6 to get this difference over here. So minus 39 plus 6 is minus 33. So I must subtract 33 from 109, which gives me 76. So your answer to 3.1 is 76. That is your next term. 3.2, calculate the formula. Now the formula, you are going to need your 3 other formulas. Remember 2a, 3a plus b, a plus b plus c, and this tn formula. And you need to know them out your head because they will not be in the exam papers. Okay, so our first one is always 2a. So remember, you let 2a equal your second difference, which is 6. So a is equal to 6 divided by 2, which is 3. Okay, your next formula is 3a plus b, and we move 1 up. We let that equal to minus 51. But we have already calculated a, which is 3. So we're going to say 3 times 3 plus b equals negative 51. So if I take everything over, b is equal to minus 51 minus 9, which is minus 60. Okay, so that's that one done. Then your last one is a plus b plus c, which we must make equal, if you go one back, 244. That is your first term. And then you replace with what you know. So a is 3, b is minus 60, and c we need to calculate. So if I take 3 over, 244 minus 3, then I must plus 60, because if I take it over, it becomes positive. So c is equal to 301. So my final formula, Tn is equal to an squared plus bn plus c. We know that a is 3, so it's 3n squared. B is 60, so it's minus 60n. And c is 301. Okay, so that's your formula there. 3.3. Which term has the value of 508? Whenever they say which term, you know you are going to let your formula equal that number. So we're going to have 3n squared minus 60n plus 301 equal to 508. Okay, now this is clearly a trinomial, which means you're going to let it equal to 0. So I'm going to take everything over. So it becomes 301 minus 508, which is negative 207 equals 0. Okay, now it looks like everything is divisible by 3 here, so let's just check. 207 divided by 3. Yep, it simplifies down. So this becomes, if I'd say this one divided by 3, it becomes n squared. 60 divided by 3 is 20n. 207 divided by 3 is 69. Okay, so now you come up with your two brackets. Clearly a plus and a minus, n and n. Your factors of 69, which will make 20 with a plus and a minus. So let's check. Let's go for biggish numbers. Let's try 13. No. Okay, let's try 3. 3 and 23. That works. Okay. So, yeah, guys, remember with this, you just play around with the numbers. 3 and 23 works for 69. So which one is going to get the plus and which one's going to get the minus? Well, clearly 20 is negative, so we'll make it negative 23, and we'll make it plus 3. Okay, so therefore n either equals negative 3 or n equals 23. So of these two answers, which one is correct? It's going to be 23, because your n cannot be negative. The same way when I made that mistake earlier. Where's it now? There it is. When I got it to be 29.6, that can't exist because it needs to be a counting number. The same thing with negative. It cannot be a negative number because it must be a counting number. Okay, I'm just concerned that I'm running out of time on the video, so I'll end this and then I'll continue on a new video.